So we all know and recognize that the way we work today is changing, and not only the tools that we use, but also our work processes. And this is true with BIM, and still is true with BIM, and it's also true with data. And these changes have implications both for practice and for education. Now, specifically, these new approaches to access, capture, store, analyze, model, and apply information that we have available to us today are being utilized by practitioners, owners, consultants, educators. And so over the past couple of years, I set out to discover and to record these approaches for capturing, analyzing, and applying building data. And so today, I'll share with you a bit of that research, as well as a few of the examples and case studies to illustrate how data is being leveraged today in our profession and industry. And near the end of my presentation, as Annalisa alluded to, I'll introduce you to the 5 out of the 25 overall strategies that are represented in the book that practitioners are using today to leverage data in their practices. These are strategies to help get you started working with data in your own careers, teams, and firms. So one question you can start with is data the new sustainability? And it is not indeed the new sustainability in terms of being a trend or being trendy, but it is like sustainability in another important way. And that is, you may recall a few years ago, we were just like getting a learning unit for attending today's webinar. We used to get sustainability learning units. And the American Institute of Architects a couple years back decided that sustainability was something that was integral to everything that we do, all the decisions that we make. It's a part of being an architect, a design professional, engineer, contractor, and it's not something separate that we needed to focus on because it was part of every decision that we made. Well, data is very much the same way in the sense that it's part of the air we breathe, it's part of every drawing, even an analog drawing that we make. It's an integral part of all the decisions that we make. In that sense, data is the new sustainability. Now, my own interest in researching data, and in particular big data, goes back not too long ago, less than 2 years ago, where through a blog by a very similar name to my book on data-driven design, I researched the way that big data was being used in the AEC, architecture, engineering, construction industry, and in part because people like McKinsey Global Institute and others had looked at the major industries and markets that were leveraging big data at the time. And you can see from this next slide that construction kind of got the short shrift or the short end in terms of being perceived as a big player in big data. In fact, it was perceived as being a relatively small player. And my contention was that this was a misunderstanding of how we leverage data in our industry, how we're looking at it. Yes, maybe the big data that we're using isn't as big as real estate data or from the hospitality industry, but it was, it's still, we have large amounts of data that we use. And so I set out with my hypotheses that we are indeed working with data in our industry to see who exactly is doing it and how are we doing it. Now, it is true that in terms of volume, as I just mentioned, we don't have as much data. If you think of it in terms of bars on your smartphone or your cell phone, we're pretty low in terms of volume, velocity, and veracity for data, and only in terms of variety, because we work with drawings and models and photographs, we have a little more variety than these other Bs. Now, that said, I think McKinsey Global Institute and others misunderstood that, you know, as we transition from CAD to BIM, building information modeling, specifically with Revit, MicroStation, ArchiCAD, and others, we are building up the variety in the types, in the kind, and the amount of data that we have at our access in our building information models. But other things are working against us as well, starting at the bottom with market fragmentation, the fact that we continue to work in silos in our industry, the fact that we have specialization. And unless we're working on integrated teams, we're not necessarily communicating the data that we work with to others up the food chain. But we're also, of course, it goes without saying, the AEC industry, we're very risk-averse, and I'll allude to this a little bit later in the talk. I'll talk a little bit about construction data. And we also make relatively small amounts of research and development investment in our organization. There's absolutely great exceptions to that, and those are the people that I turn to in a lot of cases for the book to see who's at the forefront of the data movement in terms of answering questions. How is it being utilized? How can it be utilized in the future? So I did, as Annalise had mentioned, write a book back in 2011, Great Design, and there I was primarily looking to see if building information modeling, as Paul Teichholz and others at SciFi at Stanford University had researched to see if we were making productivity progress in our industry, and with BIM alone we were not. And it was my hope that BIM tied with integrated project delivery or with hybrid forms of integrated design that are non-contractual, we would make progress. So you can see from this chart in 2012, and with more recent writings and research from Paul Teichholz and others at AC Bytes, we are not making progress. So it is my hope then that with data-driven design in our industry, our leveraging of data, that we will be able to make progress. And that's not going to happen until we all find ways in our industry, again, architects, engineers, contractors, but also owners, educators, and consultants get on board fairly quickly with looking at the data we already have available to us and then finding ways to leverage it. Now, many of us are experimenting with data, whether it's considered big data or the data that we have in our models. We're messing with it, we're experimenting with it, we're looking at it in new ways, some to great success and some not so great. But all of that is well and good, because with experimentation we learn from our failures. And we're in a stage right now in our industry where we're just getting started. So if you haven't been on board working with data, whether it's big data or any form of data in our industry, it is not too late to get on board. Part of what's enabling our ability to access data out in the field and through our models is we have sensors available to us. We have VR and AR, virtual reality and augmented reality. Just the other day, for example, 1 million Google Cardboards, which are virtual reality headsets in partnership between Google, in this case with the New York Times, were sent out with the Sunday newspaper. And more people are trying to get comfortable using the headsets, getting comfortable working virtual reality directly from our BIM in a lot of cases as well. And of course, with the big investment from Facebook, we're going to see more and more of it, not less and less. Also, in terms of cloud computing, that has enabled us to access data in real time, to work collaboratively in real time, and to, most importantly of all, make decisions, smart decisions, and to that lead to action in our industry. So starting with sensors, just look at these very quickly. They're getting smaller, microprocessors, sensors we're able to put in our clothing. We can access behavioral data when people walk through buildings today, in part because of their smartphones, and we can leverage the data dust that they leave behind. But also, just for research reasons, we have sensors that can be sewn into clothing. Microprocessors like Arduino boards are available, and we're starting to work with those as well. As an architect and a designer for over 30 years, one of the challenges I've had personally is to find ways where we leverage the data in our projects by using sensors and microprocessors, but to do so in a very humane way where people may be taxed for their information. In exchange, they may get a reduction in rent that they might pay in a housing project, for example, in exchange for the data that we gathered from them. When we work on projects like that, part of our charge as designers is to find ways to make the data sensors and microprocessors and other technology and tools to go away and become integrated into our systems. Now, you can, in addition to webinars and lectures, presentations at conferences and articles online, you can learn a lot about data and big data through books that are available to us. But my own personal feeling was when I started the research, a lot of the books end up quoting a lot of statistics and factoids. And these things don't help us with our jobs as design professionals. Anyone in our industry is pretty much wowed by this information, but it's not really helping us with our jobs. So I made it my focus in data-driven design and construction in the book to make sure that everything in the book is actionable, that it's fairly practical information. I did speak to theoreticians and academics who are doing important research because we're going to see that research leveraged in the near future in practice, not for its own sake. So in the book, I wanted to make sure that everybody who reads the book or listening to this webinar gets access to information that's being leveraged today in the industry. So I talked to 40 individuals, that's 30 practitioners and 10 academics, a total of 40 experts, innovators, and thought leaders in the industry who are currently accessing and capturing, analyzing, and applying data in their day-to-day work and research. And these individuals, of course, belong to firms and organizations large and small. I'd be remiss in not pointing out that I also spoke with building owners, because building owners are a very important entity in the AECO, architecture, engineering, construction owners or operator industry. And it's really important to find out how they are looking at data, because it's going to work full schedule, full circle, where they come back to us, design professionals, based on the way that they use data, the data that they need in operations, maintenance of their organizations, and buildings that we design. They're going to come back to us and asking for very specific things, much in the way that they're asking very specifically today, or starting to, in the way of building information modeling. Another thing that I made sure that I did in the book is not just tell the success stories. I think too often in architecture, unlike aviation, as Chris Pike with USGBC alluded to in the book, we tend in the AC industry to really talk up the things that work, and maybe it's for insurance or legal reasons. We don't too often talk about the failures or the things that don't work. So make sure in the book to represent how firms, large and small, are leveraging data or trying to, or having a really hard time doing it, what they need in the way of resources, information, and having the right culture and mindset to make it work. So when I talk about data, while I don't want to take a deep dive in the webinar in terms of how it's defined, it's covered in depth in the book. I do want to point out that very early on in our field, we have drawings going all the way back to the Renaissance that were looked at in terms of data. But up until recently, we primarily looked at data in terms of building geometry or building form. And it's only in the last decade or two that we really started to look at building performance data. And so I think when you look at a Venn diagram like this, it's important to look at the sweet spot, in this case, between geometry and performance. And only recently are we starting to look at the same time, not as a separate exercise, but at the same time, at how we are performing within our buildings, in schools that have daylight, for example, in doctor's offices that have the lab or tech rooms, or the patient rooms that are placed closer, or more of them, to where the doctors are located and the nurses are located, and the effect it's having in terms of improving owner outcomes and patient outcomes, for that matter, as well. So we look together today at geometry, building performance, human performance data, and the goal ought to be where all this is put together and integrated, where we're not separating, just having conversations today about geometry data. Even at a computational conference, I would expect the subject of human and performance data to come up as well. One of the arguments or discussions that occurs in the book between individuals, teams, and firms is the focus on whether the focus should be on data or whether it should be on algorithms that we're leveraging in our industry. And so in a very capsule or cartoon way, one side would say everybody's at a point where algorithms are good at automating geometric model generation. Jonatan Schumacher with Thornton Tomasetti Core Studio went on to say the bigger thing is the data that comes with it. So you might say Jonatan's on the side of data, that algorithms are well and good. We have those worked out. We're in our computational tools. We are doing a good job of leveraging those. It's really the data that it's all about. Interhuman with NBDJ goes on to say data itself is actually beside the point. In my eyes, the important thing is algorithms, what you do with data and how you do it. And for me personally, it was very gratifying and thankfully, gratefully, so that when I talked to the 40 individuals, including Interhuman, nobody blinked. It was pretty amazing. You think about an abstract subject or a subject that's fairly small, considered the bigger issues of resiliency and affordable housing and other major issues that we're dealing with in our industry. Data is a relatively small topic, and I was pretty happy and blown away with the fact that all 40 individuals immediately were able to answer 10 to 20 questions right off the spot to discuss the subject of data in depth in a passionate way with lots of extra information, going on for 45 minutes to an hour and a half, these talks and conversations on data, which means that there are a lot of people really thinking a great deal about it. But that said, there is a perception in our industry by many, and it may include many of you tuning into the webinar today, that data itself is dull, it's a commodity, it's not seen anywhere near as sexy as forms. When I talk about geometric or geometry data, a lot of architects would still side with form as being much more interesting to shape themselves than to have the data shaping the form. A lot of people will agree, myself included, that data itself does nothing. It's not until you feed it into an algorithm, it's not until you start messing with it or asking it questions, until you start inquiring to our models and working with data. It's not until then that data really is answering questions and helping us. And many people, both in academia and in practice, are scared by data. My colleagues included throughout the world in academia who are brought up in a certain school of thinking about architecture, engineering, construction, civil engineering, construction engineering. We think about our building projects in certain ways. And this idea that this foreign entity is coming in from the computer science realm into schools of architecture, engineering, construction is threatening, and it's scary to a lot of individuals. It's threatening to practitioners as well that were brought up with May lines or other earlier technologies before CAD and BIM were introduced. And then you recognize, as I mentioned before, data goes back to historic times. So it's not even something new. Why are we fetishizing, or why are we making a big deal out of it? One way I like to look at where we stand, you attending this webinar included, is to look at something like a version of the height cycle. So the good news is that as an industry, we're beyond ignorance, which is great. A lot of you have read articles, picked up books, you've attended presentations. More and more design consultants are holding conferences and symposia on the subject of data and architecture, engineering, design. So we have moved beyond indifference, which is huge, especially to a book author like myself and Professor, because I'd like to know that my audience, including me at 8 in the morning, my students are interested in the topic enough to dig in deep. Now, those 40 people I spoke to are much closer to where you see the red cross in terms of acceptance. They're all and completely on board with data, and so I'd like to see more and more people move from here to here. And I'm hoping something like my book and some of the presentations like this webinar will help move that along. One of the impediments that we're dealing with in our industry isn't data itself. It's not doing analysis, because many people are doing that as well. Certainly not visualization in terms of rendering or modeling, or even data visualization. A lot of times that is happening directly in the tools that we use. but it's actually this fourth quartile. It's the validation. So architects are very comfortable with ambiguity and uncertainty, and they go into architecture, for example, because they can keep the balls up in the air as long as possible before a decision is made. And what data does can be very threatening, scary to design professionals, and that it validates a lot of the decisions we make. That it validates things in real time using cloud computing. It validates decisions that we made prior. When you do a post-occupancy evaluation, the data may tell you that the building that you designed doesn't actually operate the way that you thought it was going to perform. And that's frightening to a lot of design professionals, and a lot of design professionals like to stay away from data, I think, just for that reason alone. Now, as a professor, it's fairly easy for me to introduce to the other maybe colleagues, but also to the administration or class on buildings as buildings. Think of design studio, buildings as documents. I teach professional practice as well. And talk a great deal, teach construction management, construction courses, talk a great deal about documents and buildings as design intent documents or constructability documents. In either case, they're buildings as buildings and buildings as documents, and historically that's how we taught our class. But only recently are we starting to look at buildings as databases, looking at our building information models, for example, as being essentially spreadsheets or databases that have a friendly user interface that looks like buildings, because we feel pretty strange being architects, for example, or engineers working with spreadsheets all day. But those that do work with building information models recognize before too long that really what they're doing is putting information model and trying to find ways to capture and analyze the information and apply it through the food chain. I love these two quotes. So people are getting the wrong impression where Revit value lies. It's a database. We really need to start treating it lifelong. This comes from Sean Burke at NBJ, and it's entirely true that many people are working with Revit. Certainly my students are learning to work with building information models, work specifically with Revit and other related tools, and they don't know. I mean, no matter how many times I tell them, they don't know that it's essentially a souped-up spreadsheet that they're working with, and that spreadsheet's really going to make data, help them in their careers, help them on their teams, and help their firms win jobs and move forward. I also love this other quote from Bob Uri with SLN. Revit provides a database with a graphic front end for hardcore data gathering. It's the gateway drug of sorts. And so it's one thing to attend a webinar, but it's another thing to actually work with the tools and realize you're working with the tools, let's say, primarily for documentation or for visualization for your clients. But in the meantime, you also have gotten comfortable with the user interface and with the tool. You want to take it to the next stage. And one way you move up in terms, speaking in terms of dimensions, fourth dimension, fifth dimension, so on, is to think in terms of the tools we use to see a database. Michael Kilkelly with Space Command, and also with a wonderful blog, ArcSmarter, has a case study in the book where he leverages his Revit models for a client that has many, many warehouses in terms of looking at inventory. Now, we have tools that can do data visualization, such as Tableau and other tools, in a 2D way. So in a two-dimensional way, it's fairly easy to explain to an owner through means of data visualization how much inventory they have in the warehouse. So we, as architects and engineers, contractors, leverage building information modeling currently to build models of our building. But we can also be building models of the inventory and treat it as an additional service that owners then will look at and leverage. So this is something that owners are starting to recognize and hire their experts to do on their behalf, using very similar tools or the same exact tools that they're currently using. And many smart people out there are also looking at ways to do really smart searches of their building information models, where they can query the model looking for specific, not just locations within the model, but look for pieces of equipment looking for components and systems, even building materials within the model. Others, such as Case, which is currently the guys working with WeWork, came up with these fantastic dashboards that can tell you how your hardware, but also your software is doing in terms of productivity and efficiency. And you can make adjustments along the way based on that feedback loop that you get by looking at dashboards. So I think a lot of times we are a little fearful of working with data, and certainly with algorithms, because we associate with robots and machines. We think that we're going to lose touch with our ability to provide services for our owners in terms of adding meaning to the places we design, add emotion to the designs that we make. So we often think of being at the low end of the data scale as being more human, and we think of data-centric firms, or firms that are leveraging a great deal of data as being more machine-like. And part of my research and the outcomes is that actually this is not the case at all, that we're, as you'll see in a moment, sort of counterintuitive, but data-driven firms are where data is the primary priority, where maybe up to 80% is the algorithm or the machine making the decisions, but 20% can be thought of as an override or intervention. So there are stories that come out of firms like Adidas where they'll run all algorithms for a building design, and all the windows and doors in the optimized design will be on one side of the building. They recognize immediately that that would be foolhardy to present that building to the users and owners and so on. And so they override with common sense and with emotion, intuition, and so on. Data enables is at the other end of the spectrum, where one is aware of the data but not leveraging it. And data informed, you can think of it as a sweet spot between the two, represents the middle ground, using data as a factor in decision-making process, but not the whole thing. So with data-driven design, those firms like Adidas and Flux, and Cataldo and others are capturing a great deal of data, and solutions that they come up with are developing small, quick parts of the process. But a partner at Adidas, Zig Rubel, lets us know that the fear that people will think computers are going to make the decision, he doesn't see that happening anytime soon. This is coming from a firm that grew out of the chip-making process that leverages algorithms in the design process. And anyone who thinks that algorithms are going to lead to inhuman or machine-like solutions just needs to look at the work that Adidas has done, where they have actually leveraged the algorithms to win design competitions up against design firms. And I mentioned Cataldo in Germany. As, you know, when we think of predictive analytics and the way that Amazon can predict what book you're going to be interested in next, Cataldo and other companies that do turnkey solutions for owners, modular solutions, can anticipate what your needs will be, will have an inventory of building components, and be able to deliver an entire hospital to you by next Thursday. So when I said that data-driven firms are counterintuitive, one of the outcomes of my research was to discover that there's more culture and intuition involved in a data-driven firm than technology. That you would think that a data-driven firm is a firm that's all over the technology, but actually culture plays a much bigger part in those firms. I love Andrew Human with MBBJ, his quote, "We are informed by data and frequently use it in their organization to drive their design. But if an algorithm is driving the car, we've always got a hand on the wheel." So again, we think of this as a continuum. On one end, emotions, and the other, objective data. But I think it's actually much healthier to look at data in a different way, much more as a continuum, where our data is informed by intuition. And importantly, data not only is informed by intuition, it's actually improved, where it's improved by intuition, and vice versa. Jonathan Broughton with Allies and Morrison in London, data wrangler with the firm, said Sherlock Holmes was highly intuitive, but only after he had collected sufficient data to eliminate the false positives. And this reinforces that idea that We work with intuition and with data in a continuum. We're looking for ultimate justifications for architectural acts and not to try to rationalize or post-rationalize our decisions. In terms of a hierarchy, we're looking for analysis, even above and beyond data. Again, in order to make decisions today that go beyond the rules of thumb, or even worse, the heuristics or bad data that we've worked with in the past. And the ultimate goal, again, is even beyond decision-making, is to lead to actions or actionable steps or strategies we can take to help make our industry more productive and our firms as well. So instead of thinking in terms of the DIKW pyramid for data, information, knowledge, and wisdom, I like to think of it in terms of working towards action, that's the ultimate goal, and also in terms of thinking of it as a continuum. As I said, it's not a pyramid necessarily, as you're working towards a goal, but again, the wisdom and action that you take will inform the data that you gather the next time out. Also, I think it's really critically important to look at the firms that are working with data today to recognize that many of the people on board, many designers, architects, engineers, contractors, as you see on the far right-hand side of this list, are working today with others from other industries. And the question comes up is whether the data person will sit in the corner of the office and come on board as a non-billable team member in a firm, or whether they'll be part of the billable team working in an integrated way. A lot of people I spoke with for the book said that the latter strategy or approach is the way to go. You can have data people sitting side by side with hackers, algorithms, architects, and by that I mean design architects, engineers, contractors, and so on the team in a way where they're working in an integrated way from day one on the project. But as a professor, an interesting question comes up is, do we really want to learn from each other later in the game, or do I want to have students, me and my colleagues, have our students be exposed to this much earlier so that way single-handedly they're able to leverage the ability to code, hack, program, work with data, build algorithms. Also looking at firms today, what role will firms have moving forward into the future? And instead of thinking of ourselves in a very isolated way as architecture firms, engineering firms, contractors, we can think of ourselves as digital middlemen, connecting the early phases of the project with those at the far end who will actually build, but also more importantly, use the building. Think of ourselves as information intermediaries. It's a way to redefine ourselves in the industry. One of my experiences in the book was, you can think of it as bookends, where designers on one end and owner-occupiers and operators at the other end were incredibly cooperative with me in terms of sharing data. And I don't know if it was passive-aggressive, I don't know what the reason is, but contractors in the middle, represented by these books in the middle, they were willing to talk, they were willing to share information, but none of them would sign off, not a single one, in terms of signing the forms that you have to sign for legal reasons so their information can be used in the book. They were unwilling late hour to do that. So I think Tyler Goss, formerly with Case, now with Turner Construction, said in proposing platforms, what he ran up against culturally in the construction industry was, show me 150 projects where this has been deployed successfully. In other words, previous decisions and previous experience tends to drive the decision-making in construction firms, whereas operators, owners, and to a large extent designers rely on data more and more. And some very quick examples. Professor Mehdi Gopalvar-Fard at the University of Illinois in Civil Engineering and Computer Science has created some tools that are crowdsourcing information. We're not adding on new technology and tools that contractors or architects doing field reports and field observations need to learn. This information is crowdsourced through photographs or videos taken at the site by many, many different people. And in this case, is showing in a building information model, a part of the model from a schedule or 4D standpoint, in green that's on schedule or moving forward, and the part in red that might be behind the schedule. Likewise, using new tools such as semantic analysis and automatic visual tracking, we're able to find out and optimize operational efficiency and carbon footprints based on the equipment, but also the people out at the site. So while the emphasis is overwhelmingly on analysis for building geometry and energy and so on, we're also really interested today in how people are using spaces. I had mentioned before in doctors' offices, looking at the data in terms of how people are working, specifically with behavioral performance to optimize the number of patients that can be seen, so doctors can spend more time with them. People working in organizations, how they talk to each other, who they talk to. Maybe they should be sitting closer to each other, teams that tend to need each other. Or in the case of MBDJ, looking at organizations and firms, both in terms of behavioral performance, how many calories are burned on a day-to-day basis, but also who's talking to whom physically in a three-dimensional way over multiple floors in an organization. This is the type of data that's being looked at. Likewise with Sasaki, here this shows which professors and academics are working with other academics and administrators and where those clusters are occurring. And that kind of data dust information as well occurs off universities in urban settings as well. So the acquisition and leveraging of data will become a critical practice approach, but it also begins in school. Many of my students are currently working with tools like Safari and other tools, energy analysis within Revit and other Autodesk tools. They are able to do searches within the organizations of their projects and gather a great deal of information about the projects as well. So data changing the way we work in our industry. It's also having a huge impact on the way that we learn and get these feedback loops again, in the way we have dashboards. They're constantly feeding us information. This work with RTKL that helps to inform how the building ought to be shaped, help them make decisions along the way, or the way that, for example, using the physics engine, Kangaroo with Grasshopper at Thornton Tomasetti's TT Core group, the R&D entity, where the model turns red, where the state the penalization of a project up in Canada, maybe went a little too far based on the constraints in the model, and turns green right in the model itself, where the analysis doesn't have to be taken elsewhere. And we're also seeing more and more through Flux and TTX over at TT Core, Thornton Tomasetti, seeing tools that talk to each other more. Brian Wheeler, I love this quote as well, that sometimes working with data in the academic realm, working in education and training, we tend to over-rely on data, and sometimes it removes our critical thinking. So fairly quickly, I'm going to go over the 5 strategies that I promised you. And these 5 out of the 25 in the book, I feel personally, will help you get a start in working with data in your organization. The architecture profession and construction industry have always trailed mainstream technology. Case, who again now is with WeWork in terms of heading up research and development with WeWork, did his panel suggest one way to keep up with it, or even stay up with our industry, is to look at articles such as from TechCrunch and others from 5 years ago, because if you look at other industries, then you can see not only that we're behind, but that we can be making improvements where we need to be. Also, Mads Jensen with Safari, the CEO, said, the short answer for him is that we are really just standing on the shoulders of advancements that were made in computer science and others decades ago, and so we should look to other industries in order to make improvements and progress within our own firms and teams. Also, I love what Evelyn Lee with MKC in California said. It's not really big data that we look at. We should think in terms of what the data that we're using to do for our clients, and we're trying to find the right balance in the data that we're working with. So her strategy is to think in terms of big data, it's smart data, not so much as big data. Another strategy is to ask questions of our data. Does your firm, do you personally, your firm, your teams have capacity? And that includes resources, but also secondarily, the second bullet point, mind space. Do we have the right culture in our organization to work with data, the right people on board? Do we have support from the leadership in the organization, but also from the emerging professionals, the interns, others in the organization? We need support from both ends for this to work. Do we have a way within HR, within accounting, but also in terms of performance in others in the organization to measure the outcomes? Do you have enough time and resources to take this on? And lastly, a last or eighth question to be asked is, do you have the right attitude or mindset to work with data within your organization. So there's a lot of writing here, but with this, these 4 steps were suggested by Andrew Human at NBVJ. Learn what others are doing. It's easier to recreate a capability someone else has than to come up with a brand new application from scratch. To do that, you can hire an expert who can write code, work with data, even before you get somebody full-time on board. You can, within the organization, hire or train an evangelist. They can go outside the office to learn how to do this. And it's somebody who gets it. He really watches a webinar like this, reads a book or an article or two. He can really communicate the value internally, but also externally to clients of how data can help make decisions and make those decisions stick. But also build habits of mind in the organization, the ability to identify problems that can be addressed with data in a way of thinking about the problems to render them amenable to computational analysis. Another strategy is to ask good questions. What quality mindsets or attitudes would you recommend others develop in order to work with data? These are good questions to ask that you see here. I'll read just through a couple of them. What can be measured or quantified on this project? What can be automated? How can we make this process more efficient and speed things up? What information about the task at hand that we're working on in CAD or BIM, using spreadsheets or something else, is embedded into this digital representation and what isn't? And that may help us along the way as well. I'd like to wrap up by looking at NBVJ's Hangzhou Stadium project. Andrew Human brought to my attention that Nathan Miller, now with Proving Ground, formerly with Case, was the designer working with NBVJ at the time. And I love the way that data is used in this project, because looking at one of the petals that forms the roof and the wall structure as well, using data, they can not only from an efficiency standpoint, see how they can keep the roof standing up, withstanding gusts of wind and all the other forces that go against it, but do so in a way that uses the least amount of structure, so the fewest number of trusses, but also at the same time as again, as I mentioned, as a human intervention, human override. I know it's all human, but when you think about it, which one looks best to you? Which one looks best proportionally? And a lot of times you can't just see it from this one angle, so you start looking at it from different views. You also start thinking in terms of which ones have the best sight line, and we use these computational tools and algorithms to try to determine how the details will work together. In this case, you're looking at, of course, Grasshopper with the 3D printed model in the foreground. And we're looking at sections to make sure that this all works together and the decisions we make end up in our documents and be well documented. And this all starts with data. And then, of course, even using the same programs, we're able to render different views to look at the ultimate effect. Sometimes that will inform the number, go back to the number of structural members and get that feedback loop to reassure, make sure that decision that you made is one that's going to stick. So thank you very much.